Hello, hello, and welcome to a little video about solving exponential equations with a practical application. All right, let's do one that is relevant, I think, to pretty much everyone these days, and that is banking. So, say we invest $1,000, meaning we just put it away, and we don't look at it. We're not putting anything else in it. We put away the $1,000. The bank says, hey, if you put $1,000 in, we'll pay you 4% interest and we'll compound that quarterly. To the nearest tenth of the year, how long should we leave the money in until we reach $1,600? Meaning, we're not adding any money to it. In a real life situation, of course, at least I would keep throwing money into my savings account, money that's there and ready in case of emergencies. But let's say we didn't. Maybe this is just a separate savings account, just cuz. So we want to see how long will it take us to reach, well, I guess to make $600 if we never touch or put anything else into that savings account again. All right. So we put in $1,000. That is our P, that's our principal, how much we put in. We also told that we have 4% interest, that's R, which is our rate. It's compounded quarterly, which is how many times per year, and that's our N. And then lastly, we are having a goal of $1,600, that would be A. Let's plug everything in. Okay, so we have our goal of $1,600, our starting amount, our principal of $1,000. When we put in a rate, we need to put it in decimal form. So 4% is 0.04. And quarterly means 4 times a year. Now, the first thing that I'm going to do here is kind of simplify what's in the parentheses. So I quite literally put 1 plus 0.04 divided by 4 into my calculator. And I got 1.01 to the power of, 4t. That's still there. At this point, I'd like to get my exponent on its own. So first I'm going to divide by 1,000. Oh, wow, I wrote giant. I need to give myself some more room. I think I have room on the side. Okay, so here it cancels out. And then we're left with 1.6 equals 1.01 to the power of 4t. Now what I'm going to do next is transform it into a logarithm, because that's what we do when we don't know the exponent. This becomes log with a base of 1.01, so the same as my exponent base, of 1.6 equals 4t. What I did first, before getting t by itself, is I put log base 1.01 of 1.6 into my calculator, and I rounded it. I got 47.23. Now I'm going to go ahead and get t by itself by dividing both sides by 4. And we get that it takes us almost 12 years to get those $600. Again, this is an account that you would have left on its own. You didn't put any more money in it. So that part, I think, isn't the most real life situation part of it. But the real life situation part is the interest. Now, the more money you invest in a bank, the more likely they are to give you a higher percent interest that's compounded, right? They trust you a little more. All right, so let's continue on. I would like to do an example that has a little bit more to do with science. So this is a decay problem. In this problem in particular, we're talking about radioactive decay, which can be applied to so many cool things in science, like seeing how long I guess the most obvious one is how long it takes something to not be radioactive. It's also used in carbon dating, which is how we find out the ages of fossils and other ancient finds. This is a great decay model, not particularly for radioactive stuff, but it can be applied to medicine, so how long it takes for it to dissolve in your body. This can be also applied to the healing of wounds. Of course, if there's no infection, that would be there'd be a little bit more to it if we were considering infections. But one way or another, this is a great decay problem. Let's do it. Element X decays radioactively with a half-life of 14 minutes. There are 760 grams of element X. How long, to the nearest tenth of a minute, would it take the element to decay to 11 grams? So let's see what we have. First, we have a half-life of 14 minutes. That's what the H stands for. We're also told we have 760 grams. That's what the A stands for, the initial value. Lastly, we have our goal, which is 11 grams. That's going to be our Y. Alright, let's plug things in. So we want to end up with 11 grams. We started with 760. We're multiplying it by 1/2 raised to the power of t over the half-life, which was 14. Okay, so just like in the other problems, I'm going to start off with division since I'm multiplying by that base. When I divided, and I'm rounding of course, I got 0.01 equals 1/2 to the power of t over 14. Now that I have an unknown in my exponent, I'm going to turn it into a logarithm. So I have log base 1/2 of 0.01 equals t over 14. Before I get t by itself, I'm going to put in log base 1/2 of 0.01 into my calculator. And again, I'm rounding. I got about 6.6. And now to get t by itself, we'll multiply both sides by 14. Fractions represent division, so we undo it by multiplication. And I get 92.4 equals t. So it takes 92.4 minutes for element X to decay from 760 grams to 11 grams. So what's that, about an hour and a half? Not too bad. Okay. I hope seeing these two problems was helpful. If you have any questions, please let me know. Otherwise, have a wonderful rest of whatever day it is for you. Bye.